Hello there, Wildcats. Welcome to your Algebra 1 class, and we're going to continue factoring polynomial. At this time, we'll be factoring in the form of ax squared plus bx plus c. So if you see this type of polynomial, it is quadratic because the degree is on second degree, and there are three terms there, so we can call it quadratic trinomial. So our objective for today is we're going to identify common factor of the coefficient in the terms of a trinomial expression when a is not equal to 1. And then second is we're going to write quadratic trinomial as a product of two binomial factors. The essential understanding here is a quadratic trinomial in the form ax squared plus bx plus c when a is not equal to 1 can either be factored by grouping or factored by substitution, but we'll focus in this video, we'll focus on groupings and any other ways of factoring. And also in this video, we'll also be doing factoring special cases. Our objective on special cases would be identify and factor a trinomial that is a perfect square or binomial that is a difference of two square. And then we're going to use polynomial to represent the measurement in a real world situation and describe how a factored form of a polynomial relate to the situation. Essential understanding: when a trinomial has a pattern a squared plus 2ab plus b squared, then it is factored as a plus b times a plus b, or a plus b squared. When a trinomial has a pattern a squared minus 2ab plus b squared, then it can be factored as a minus b times a minus b, or a minus b squared. When a binomial has a pattern a squared minus b squared, then it can be factored as a plus b squared, a plus b times a minus b. Okay, so those are our objective on factoring polynomial in the form ax squared plus bx plus c. And also we are going to factor special cases in this video. All right, so let's start with example number 1. So example number 1 is we're going to factor out a common factor given 3x cubed plus 15x squared minus 18x. Now we said that, Mr. You said that it is in the form of ax squared. So the highest degree is would be on the second degree, but this one it's in cube. That's why we are going to factor out in such a way that you will be arriving, or you will be having a an expression that has the highest degree would be on second degree. Right? So our essential question in this example, or in this factoring ax squared plus bx plus c, would be: how is factoring a quadratic trinomial when a is not equal to 1 similar to factoring a quadratic trinomial when a is equal to 1? Because in our last topic, the value of a there is 1, so we just focus on the middle term, which is your b, and the last term, which is your constant c. Now we are going to use the same, okay, the same way of doing it. Okay, so in our first example, before factoring the trinomial into two binomial, look for any common factor that you can factor out. So I was looking at my given right now, and I have to look for a common factor, which is we did what is the GCF of 3x cubed, 15x squared, and negative 18x? So basically, the common here would be 3x. So common factor is 3x. Would be put there 3x. So the next thing you have to do now is then you have to move out your 3x outside your parentheses, and then you have your quadratic inside your parentheses. So 3x cubed plus 15x squared minus 18x would be, you can factor that as 3x cubed plus 15x squared minus 18x can be factored as, so you have 3x outside your parentheses, and then you have x squared plus 5x minus 6. Okay, so we did factor using a common factor, which is the 3x. And now, as you can see here, your a now, the value of a here, it's 1. Remember, we did factoring polynomial when a in ax squared plus bx plus c is 1. So we're good to go from there. Think of two number again that if you multiply will give you -6, and when you add will give you +5. So we are now factoring this one. So what is the factor? What is the factor of x squared plus 5x minus 6? So what is the factor of -6? And then the sum of the factor will be +5. So thinking of that, it would be -1, and it would be -1 and +5 or +6, because 6 times -1 is -6. 6 minus 1 it's 5. Therefore, to factor it completely, we can now put there 3x times x minus 1 times x plus 6. So this is now the complete factor of 3x cubed plus 15x squared minus 18x is equal to 3x times x minus 1 times x plus 6. Remember, in our vocabulary, the answer, okay, the answer 3x, the quantity x minus 1 times x plus 6 is 3x cubed plus 15x squared minus 18x factored completely. Okay, it was factored completely. There are other ways you can factor the polynomial, but only one way to factor it completely. So this is now the factor of our given polynomial. Okay, right. Let's go with our next example. Now, in this example, example number 2, is another way to factor. So we're going to factor by groupings. If ax squared plus bx plus c is a product of a binomial, how are the values of a, b, and c are related? So we are going to consider this example that we have here. Okay, so a tip for you guys is that to speed up your search when looking for a factor pair that has a sum of b, you can rule out factor pairs with sums that are obviously far from the target. Okay, so let's take a look at this one. So we have 6x squared plus 11x plus 4. So identify your a. So first, I will identify my a, b, and c. So my a here, maybe I'll just change color there. So my a, is equal to 6. Just the coefficient, guys, okay? B is 11. And then C is equal to 4, right? And then First is you have to take the product of A and C, right? So what is the product of A and C? So product of A and C, A times C is equal to 6 times 4, which is equivalent now to 24. Okay, and then we are going to find the factor pair of 24 with the sum of 11. So maybe I can use a table here. Factor of 24, but when I add will give me sum is sum of factors, which is will give us it must be 11. So it must be 11, right? So I'm so sorry about my handwriting there. Okay, so we have 2 and 12, but the sum is 14, 3 and 8. 3 and 8, so we have 3 times 8 will give us 11. So we'll be using 3 and 8 as a our factor here. So from there I can now factor I'll just change color of my pen here. We can now factor 6x squared. 6x squared plus 11x plus 4, which is we know that we have 6x squared plus 3x. It's from here, 3x, and then we have plus 8x, and then of course plus 4. All right, and then because our strategy is we are grouping them, so I'm going to group them in such a way that I have first group would be 6x squared plus 3x, and then plus, this is my second group, 8x plus 4. Okay, and then from there you can factor out the GCF of each binomial. So what is the GCF of 6x squared and 3x would be 3x. Okay, that's 3x, and then 2x plus 1, and then plus, what is the factor of 8x? So it's 4. So this is 2x plus 1. Factor, the common factor now on the first binomial, the greatest common factor of the first binomial is 3x. The greatest common factor of the second binomial, which is the 8x plus 4, is 4. Now, as you can see, both of this has a common, which is 2x plus 1. So 3x times 2x plus 1, and then 4 times 2x plus 1. So I'm going to put them together, and then I'll add 3x plus 4. So the factor, so you can now say that the factor of 6x squared plus 11x plus 4 is equal now to parenthesis 3x plus 4. Where did you get that? 3x plus 4 times just a single 2x plus 1. And you are done there. Okay, so that's the factor of our given trinomial. So the factored form of 6x squared plus 11x plus 4 is equal to 3x plus 4 times 2x plus 1. So if you want to check, you can work on distributive property. Okay? All right, one more example here. Let's see. Oh, so we have 2x squared plus 7x plus 3. First is identify your A, B, and C. So I can't see my pen, that's why. All right. So I'm going to identify my A, B, and C. So my A, it's the coefficient. I'm talking about the coefficient. B is 7, and then C is 3. First is I'm going to multiply A times C, which is 2 times 3, which is equivalent to 6. All right. So what would be the factor of 6, but sum would be 7? So this, what is the two number that if you multiply will give you 6, but when you add them will give you 7? What would that be? If your answer is 6 and 1, you are right. 6 and 1. Because if I add, it will give me 6 plus 1 is 7. 6 times 1 is 7. Now, I'm going to factor that by grouping. We have 2x squared plus 7x plus 3 is equal now to 2x squared plus 6x plus 1 or plus x. I'll just rewrite that again, plus x. So plus x plus 3. And then we're going to group this. So it will give you 2x squared plus 6x. And then plus the second group is x plus 3. So you will see that there is a coefficient of 1 here because this is the simplest form now. So there's a coefficient 1, but you can see there. Okay. I have to get the greatest common factor of 2x squared and 6x. That would be 2x will be outside, and I'll just put there x plus 3. Okay, plus 1 and then x plus 3. So combine your x plus 3 together. So you only have now the final answer, which is 2x squared plus 7x plus 3. The factor of this one is 2x, not just only 2x, because you still have 1 here, 2x plus 1, parenthesis, x plus 3. Okay, so that's how we factor using groupings when a is not equal to 1. Right? Next example. Still in grouping. All right, so we're still in grouping. So first is identify your A, B, and C. So A is equal to 6, B is equal to -5, and C is equal to -4. So multiply 6 and 4. So A times C is equal to 6 times 4. That is 6, 12, 18, 24. But 4 is negative. Sorry. So this is -24. So what is the two number that if you multiply will give you -24? When I multiply this, and when I add, the sum would be -5. Okay, think of that. I'll repeat. What is the two number that if you multiply will give you -24, but if you will add, will give you -5? So if you're thinking 8, -8, and +3, you are right. So 3 minus 8, it's negative 5. 3 times negative 8 would give us negative 24. Now, we're going to factor this one and regroup that. Okay, so I have 6x squared minus 5x minus 4. That is equivalent now to 6x squared minus 8x plus 3x and then minus 4. Okay, so maybe we can rearrange that. I'll rearrange that, sorry. So you can see the easiest way to factor them. So this would be plus 3x minus 8x. And then you group them together. So first group would be 6x squared plus 3x. Then minus, so minus 8x. And then that would be plus 4. Because it's inside the parentheses of the minus here. So we get the GCF. We have the GCF of this would be 3x. And then that's 2x plus 1. And then we also have minus 4. And then 2x plus 1. So you see there's a common here. So the factor now of 6x squared minus 5x minus 4 would give me 3x minus 4 times 2x plus 1. So this is now the factored form. All right. Now I want you to take screenshot of this one, and if you have any question, you go back, and then I want you to join us in a live Zoom meeting. And this video is a discussion video. I want you to pause this video and copy this given, and then I want you to factor this one by grouping, and I want you to post your answer on our discussion below. All right. Now, next example, we're going to do factoring special cases. So our vocabulary is perfect square trinomial and difference of two square. All right, so one thing which is this one is a lot easier because that's what I've said, it's special case, and we'll learn about that. All right, so all right, let's proceed with our first example. So what is the factored form of x squared plus 14x plus 49? So we are going to understand factoring a perfect square. The meaning of a perfect square is a perfect square trinomial results when a binomial is squared. The first and the last term are perfect square. The middle term is twice the product of the first and the last term of the binomial. So when we say a perfect square, an example of this one, I'll just write and then I'll erase it. And if you want to go back and copy, you can still go back using this video, guys. So we can say that if we have a plus b times a plus b, we can write this one in such a way that you have ab and then you have the square there, meaning you have to double your base, and a plus b is a group and then we consider that one as a base of this one. And then your answer in here would be in standard form would be a squared plus twice your AB when you multiply them, and then your B squared. Okay, so if you also have A minus B times A minus B, the same way, so we have A minus B squared. However, you have your A squared minus 2AB plus B squared. Okay, this is what we call now your perfect square trinomial. Right? So I want you to pause this video and I want you to copy that. All right. So I'll just erase that and we will answer this. Okay, if you will notice that the middle term or your value of B is 14 and the value of C, okay, the value of B is 14 and the value of C is 49. So thinking about what is the factor of this two number, that if I multiply this number will give me 49, and if I'm going to add will give me 14. It would be at the same number. All right. So write the last term as a perfect square. Okay, so I'm going to write x squared plus 14x plus 49, and I'm going to write the last term as perfect square, which is the square root of 49. Okay, the first and the last term are perfect square. The middle term is twice as the product of the first and the last term of the binomial, basing on the definition of a perfect square trinomial. You know, the square root of 49 is 7, so I have here 7 squared. And if you will notice also that 7 plus 7 will give us 14. So it says there that as twice as, so 2 times 7, right? 2 times 7 is 14x plus 7 squared. So I'm just following the definition of a perfect square trinomial. Therefore, there are twice as x plus 7 and x plus 7. So we can now say that our factor here is x plus 7 times x plus 7. Okay, x plus 7 times x plus 7, or the factor would be x plus 7 squared. X plus 7 close and then squared. Remember that your 2ab, 2 times a times b, is equal to 2 times 7 times x is equal to 14x. So the trinomial fits the pattern. So we are looking at the pattern. So we can now say that we have x squared plus 14x plus 49. That's 14x plus 49. The factor would be x plus 7 squared. Now, I'll just want to give emphasis on the common mistake or common error. Be careful to identify the correct values of A and B when factoring special cases. The value of A can be different from X. Okay, let's move on to the next example. How about this one? Thinking about 8 and your 16. So it's a lot easier because we can now say that the factor of x squared plus 8x plus 16, that would give us x squared plus 4 times 2x, close that, and 2x plus 4 squared. Therefore, you can now say that the factor would be x plus 4 times x plus 4. Okay, or we can have x plus 4 squared as a factor of x squared plus 8x plus 16. Okay, our next example is when a is not equal to 1. So we have in here the value of a is equal to 4. However, it will not affect our solution to that because this one is a perfect square. So what I'm going to do is I'm going to rewrite it in this way. So I have parenthesis 2x squared plus 12 is not, and then you write this one is 3 times 3, which is 3 squared. So as you can see here, and then you factor your 2x. So I'm going to factor my 12x, sorry, the factor of 12x is 2 times 2x times 3, right? 2 times 2x is 4x times 3 is 12x plus 3x squared. So it's your 2x here. We also have 3 here. So we can now say that the factor here would be 2x plus 3 times 2x plus 3. Or you can say that the factor would be 2x plus 3 squared. So if you want to check your answer, it would be a lot easier. You go and check your answer by distributive property. Okay. Now, in our last example, it will be a blank slide. Okay. So we call this one as a factor, a difference of 2 square. A difference of 2 square, we have to determine whether the factoring rule for a different 2 square makes sense by working backward. All right, so let's say I have here 4x squared minus 81. So factor your 4x squared, that would give us 2x squared minus this 181 would be negative 9 squared. That's 9 squared. Therefore, when you factor that out, it would give you 2x, okay, 2x minus 9, and then 2x plus 9, because the middle term, we don't have any middle term here. Therefore, if I add 9 plus negative 9, it will give us 0. So A is equal to 2x and B is 9. So the binomial fits the pattern. So the difference of two squares is a factoring pattern when one perfect square is subtracted from another. If the binomial follows that pattern, you can factor it as the sum and difference. So again, your B here is we don't have we don't have b's, okay? In your pattern, we only have your ax squared, okay, plus bx is missing, and then minus c. So in this example here. All right, so thank you so much, guys, for watching this video, and I hope you learned something. And again, if you have any question, just email me, and I encourage you guys to join us in our live Zoom meeting for more example and immediate feedback on how you answer it. And then you can immediately ask question also during our discussion. And yeah, it's fun to have live Zoom meeting, guys. Join us, and I hope to see you all in our live Zoom meeting. Thank you, and bye-bye.